Hi, I'm Justin Weiss from IBM Research, and I'll be presenting our case study paper on the impact of an AI code assistant on developer productivity at IBM. AI-powered coding assistants are becoming very popular today, and last year we had the opportunity to study an internal deployment of IBM's watsonx code assistant, known as WCA. And WCA helps developers with a variety of tasks, such as generating code from natural language, auto-completing code as it's being typed, explaining code, and generating unit tests and documentation. With our internal deployment of WCA, we were very interested in understanding the impact that it had on the productivity of developers within IBM. Measuring productivity is a common desire within engineering organizations, and at a high level, Sadowski and Zimmerman offer this definition of productivity as being some measure of output divided by some measure of effort. But this is only one view of what productivity is, and researchers have since developed more comprehensive frameworks. For example, the SPACE framework outlines a wide range of metrics that can be captured at the individual, team, or system level. And within IBM, my own team has done a number of studies in the area of human-AI co-creativity, and we tend to think about metrics at three levels. The first is the artifact itself, such as how many errors a piece of code has. The second is about the work process, such as how much time a person spends on a task or how much work they accomplish during that time. And the third are human-centric measures about the user experience, such as how effective the person felt when using AI. In evaluating the impact of WCA on productivity, we focused on individual-level, human-centric metrics because of the kinds of questions about the developer experience our product team was interested in. So here's a timeline of our study. In March of 2024, WCA was deployed internally at IBM. And once developers had some time to start using the tool, we conducted two UX surveys. The first was in May with a cohort of 105 developers, and the second was in July with a cohort of 564 developers. The survey focused on a number of dimensions of the WCA user experience, and it contained a mix of quantitative and qualitative questions. A lot of these questions were scoped to the past 2 weeks of usage because we wanted our data to reflect how WCA was actually being used. The respondents to our survey were largely back-end developers, but we also had representation from front-end developers, QA and test developers, and many more specialities. About a month after our survey, we conducted a round of unmoderated usability testing to examine specific usage of the code generation, auto-completion, and chat features of WCA. And although this testing was to examine those specific aspects of the WCA user experience, we found that participants' feedback strongly aligned with themes identified in the UX survey, so we included this data in our analysis. Here's an overview of the different dimensions of the user experience we examined in our studies, and I'll give a brief summary of our results in each of these areas. The first area is about why developers wanted to use WCA, what they used it for, and why they didn't use it. And it turns out that the most popular use cases were about understanding code rather than producing it. This was very surprising to us because a lot of the discussion around AI coding assistants is how they improve productivity by helping people write code. But what we actually saw was a lot of people using WCA to explain existing code or to answer general programming questions, such as this developer who said the ability to explain code would save them a lot of time. We also saw another interesting trend, which was about using WCA to enhance the characteristics of existing code. Even though this kind of use was less popular, it highlights an opportunity for AI coding assistants to help improve characteristics like readability, maintainability, performance, reliability, and so on. There were a few reasons why people didn't use WCA within the past 2 weeks, such as it being faster to do the work themselves, it wasn't helpful, it didn't support their requirements, or they simply didn't do any code-related work. But we also discovered that some developers were reluctant to use WCA because they perceived a social stigma against it. For example, these developers commented on how it would be embarrassing to be seen including AI-generated code in their pull requests, and how they were suspicious against AI-generated code. These comments suggest that organizational leaders may need to do some work to shift their culture toward acceptance and use of AI coding assistants. We also found some cases of off-label usage by developer-adjacent roles. For example, a technical writer used WCA to explain concepts so they didn't have to bother their dev team. And some content designers told us of their desire to use WCA to help them write technical documentation. These comments highlight the importance of really understanding who is using your product and why. Now let's take a look at how the outputs generated by WCA were used. And for the most part, the different types of outputs, code, explanations, unit tests, or documentation, were not used wholesale. Rather, our developers reported modifying them in some way before they used them in their own work. And in these cases, it was the outputs themselves that were valuable. But we also discovered many cases in which the outputs themselves were used for other reasons, such as giving people new ideas or helping them learn something new. And this was an interesting result because it contrasts with how the community commonly thinks about productivity. For example, Ziegler et al. Recently argued that perceptions of productivity gains strongly correlate with objective measurements, such as accepting AI-generated code suggestions. However, we saw that even if developers don't accept generated code suggestions, they can still be valuable. Therefore, productivity evaluations that solely focus on such behavioral metrics may miss this kind of usage. Since our overarching research question was about productivity, we included a few quantitative measures to assess developers' feelings on how WCA impacted their productivity. These included semantic differentials on whether WCA made their work easier or more difficult, of the best or worst quality, and faster or slower. We also included a scale of self-efficacy, how effective they felt as a developer when working with WCA. And overall, we see evidence that WCA had a positive impact on developer productivity. All of the semantic differentials fell on the positive sides of the scale, and self-efficacy was rated above the scale midpoint. However, these results come with a caveat, and that is all of the people who provided ratings on the lower ends of these scales. It's a common finding in human-centered AI research that the performance of human-AI teams is quite variable. Sometimes people do better with AI, and sometimes they don't. Michelle Vaccaro and her colleagues at MIT did a fantastic survey on this topic, which I highly recommend checking out. One aspect that was important for us to study was the extent to which people felt ownership and responsibility over code produced with AI assistance. And developers largely did feel a sense of ownership, either by themselves or jointly with WCA across a variety of scenarios. Even in the case of pasting WCA-generated code without modification, some developers still felt that the code was theirs. They also felt strongly that it was both their responsibility and WCA's responsibility to mitigate some of the risks of including AI-generated code within IBM products, such as code that might infringe on copyright. But perhaps more interesting was how some developers told us how they wanted stronger attribution mechanisms because they didn't want WCA to steal their recognition. And this came up because it was a requirement that WCA-generated code be labeled as such. And we did a separate study to examine issues of attribution in human-AI co-creation, which is also being presented this year at CHI, and I highly recommend you check out our paper. The last category we examined was developers' feelings on how AI code assistants like WCA might impact their job role. The responses largely fell into these four categories. Some developers weren't really sure yet and hadn't figured out how to draw the line between what they would do and what the AI would do. And some developers felt that WCA would help them focus more of their attention on harder or higher level problems and innovative feature design. Other developers discussed how the use of AI might lead to de-skilling, resulting in them not doing their job as well. And one apt developer commented on how their management's expectations of their team's productivity increased because of the expected productivity gains from WCA. So to wrap up, I'd like to leave you with these three takeaways from our case study. First, we observed that WCA did lead to a net increase in feelings of productivity, but those feelings weren't evenly distributed. Some people still struggled, highlighting the difficulties of designing effective human-AI collaborative systems. Second, understanding code was the top use case, which motivates the need for more research on how AI agents can help developers conduct code sense-making tasks. And third, developers felt that they had a shared responsibility to mitigate the risks of AI-generated code, motivating the need for new mechanisms to help them identify and mitigate potentially risky outputs. Thank you for listening.